So in the lecture series, in the course Material Science and Metallurgy, today in the Unit 4, ferrous and non-ferrous metals, we'll discuss what are the effects of alloying elements. You know what is an alloy? Alloy is nothing but a mixture of two dissimilar or similar metals, and one should be a metal definitely. So let us go to the next slide. In the introduction to alloying steels, these are all the crucial for modern engineering. They are added to steel, modify its mechanical, physical, and chemical properties. These three things are going to be changed when we alloy any element. So what is the purpose of alloying? Tailor properties for specific applications, enhance performance beyond plain carbon steel. Example, chromium in stainless steel for corrosion resistance. So we use all the domestic utensils in our kitchen. Domestic purpose, we use stainless steel because the chromium content is there. That will be helping the stainless steel to avoid corrosion or oxidation. So what is the primary purpose of alloying steel? To decrease its density, to modify its properties for specific applications, to reduce its cost, to make it easier to melt. And the answer is B. We are going to modify its properties for specific application. So plain carbon steel, the challenges of demanding applications. We'll see plain carbon steel, while versatile, often falls short in rigorous engineering environments. Its inherent properties can lead to premature failure. So the common issue is low hardenability, limited strength and toughness, poor corrosion and wear resistance, susceptibility to fatigue under heavy loads. So the real world example is gear failure. That's why we have seen a larger gear here. We are going to, what is the purpose of gear? Yes, gear is to transmit power from engine to tires in the automobile industry. And consider a gear made of plain carbon steel under heavy continuous loads and abrasive conditions. Such gear would be experience rapid wear, suffer from plastic deformation, fail prematurely due to fatigue or fracture. And alloying additions or elements deliberately introducing into the steel to alter its microstructure and consequently its mechanical and chemical behavior. So increasing hardenability, improving strength and toughness, enhancing corrosion and wear resistance. So which is the following is not a primary effect of alloying additions in steel. So they have asked negative or the question. So that is increasing hardenability. Yes, we are going to increase hardenability. Improving strength and toughness. Yes, we are going to do it. Reducing overall material cost. By alloying, we will never reduce cost. So since alloying is a property and cost is something different, so this is odd man out here, C. Let's go to the next slide. And the different alloying elements are carbon, manganese, chromium, nickel, molybdenum, vanadium. So each alloying element will have different effects of the effects on the steel. So carbon, it influences hardness and ductility. Manganese, it increases hardenability. It acts as a deoxidizer, forms carbides. So chromium will act as a corrosion and oxidation resistance, improves hardenability. Again, nickel, it enhances toughness, especially at low temperature. Molybdenum, molybdenum will help to maintain red hot hardness. Let us see the transformation behavior through different diagrams here. This is a very important thing in metallurgy. So phase transformations shift critical temperatures and alter phase stability. Triple T diagram shows C curve, which is favoring bayonet and martensite formation. CCT diagram is about critical cooling temperature diagrams. And there exists a grain refinement which allows grain growth, leading to fine grain structures, improving toughness. So testing alloying effects. Again, hardness, impact, and microstructure commonly used in all the material tests. And the major alloying elements and their specific effects we have already discussed in the previous slide, that has been repeated here so that you could understand the specific effects of these alloying elements. So we have engineering applications here, and properties of alloys is given as mind map. It is resistance to heat, we are going to increase it, conductivity, strength, resistance to corrosion, and weight. So with this we can understand the purpose of alloying and the effects of alloying, and each alloying element will influence the steel in different way. So let us conclude this lecture and see you in the next lecture. Thank you.